Hi, morning everyone. We're just giving a chance for everyone to sign in, so just bear with us. Just some housekeeping rules. So this session is going to be recorded, and we will be making the video available on the YouTube channel, and it will be linked or posted onto the website. During the event, if you're not speaking, could we ask you to switch off your cameras and also mute yourselves, just to help the party's broadband or bandwidth. If you have any questions throughout the event, please just type them into the chat function, and we'll raise those at the end of each speaker slot. And then we'll also have a open discussion at the end of the event. So the intent of today is to allow the speakers to provide their presentations for 7 to 8 minutes. Then we'll have a few minutes of questions and then progress to the next speaker. Time will be allocated at the end of each presentation to read out the questions, or also we'll read out any comments that parties may have. We'll also have time at the end, as I said, to just have an open discussion with the audience and also the presenters on any general findings or comments that we have. Are we okay, Catherine, to go? Thumbs up? Enough? Grand. Okay, so welcome to the Scottish Institute for Remanufacturing's PPE Waste. Is waste, PPE waste, remanufacturable? What are the solutions out there? This is a programme that was kindly sponsored by Zero Waste Scotland, and we were able to work with academia to look at some of the challenges at the time, and still quite relevant and topical today. Just to remind people, the Scottish Institute for Remanufacturing exists to support industry on their journey to adopt remanufacturing capabilities, more sustainable practices, and work towards a net zero position. We help develop innovations in ways of reusing, repairing, and remanufacturing high value components. That's not just high value in terms of low volume, large costs, but high volume, low costs in production, creating kind of high value waste streams or high volume waste streams. We create and implement circular economy strategies and business models into organisations. For the past 6 years we've been in existence, and we break down barriers to companies adopting sustainable business models, circular economy business models. Please contact us for help. We do run networking events. We have a network of academic expertise to help industry identify solutions to their challenges. We also help companies identify relevant funding support and build collaboration events and programs to support industry on their net zero journey. The agenda of today is as follows. What we will do is we'll ask the presenters to share their screen when it's their time to present, and then we'll give the thumbs up. And again, please raise any questions that you have or comments in the chat box just by placing a Q in front for a question and a C in front for a comment. And whilst presenters are presenting, please ensure that you are muted so we don't get any interference with this. So without any further ado, I would invite Andy Campbell to share his screen. I'll stop sharing. Over to yourself, Andy. You're on mute, sir, as well.
Okay, thanks, Paul, and thanks, Catherine, for organising it before today, and thanks, Paul, for the introduction. So, yeah, my name's Andy Campbell. I am the Year 1 leader at the University, at the Strathclyde Department of Architecture. So, our presentation today really focuses on capturing PPE waste and aiming to remanufacture as architectural or built environment products. I'm also a director and founder of Dress for the Weather, which is an architecture studio, and we've recently completed interiors for the Royal Hospital for Sick Children in Edinburgh and the Dumfries and Galloway Royal Infirmary. So that kind of interest in healthcare, the healthcare environments, kind of comes through from a practice point of view as well. We really tried to tackle the problem from both ends. Firstly, sort of identifying or deciding that we wanted to focus on NHS issued PPE equipment, and then from there focusing on the PPE recommended for low risk pathways, or the green pathway. And then in conjunction with that, deciding that, I suppose in line with Scottish Institute for Remanufacturing, focusing on the remanufacturing sort of element of the waste hierarchy, and how through capturing that waste, remanufacturing it, we can then lock that waste in for a prolonged period of time of at least 15 to 20 years by remanufacturing to building products or architectural products. One of the first things we did was to categorise the material that we were dealing with, and the material that we were dealing with through the low risk pathway. I think it's probably worth just saying that everything's plastic, and it maybe sounds obvious to a lot of people on this call, but genuinely when we started this project, we didn't know that everything was plastic, so that was a little bit of a surprise, especially with the face masks there. I guess that's the kind of obvious, well, the only not obvious one. But yeah, the kind of low density polyurethane for the aprons, LDPE, polypropylene masks, nitrile for the gloves, polycarbonate and PET for the goggles and face shield. And then we started to dig a little bit deeper into the NHS government figures for the amount of material issued, which are fairly kind of eye-watering. 175 million aprons issued by NHS Scotland between March 2020 and March 2021. And we went through quite a crude exercise of weighing individual items and then multiplying that up to create an approximate tonnage of PPE waste from NHS low risk sort of issued PPE. We studied the waste stream, excuse me, for single-use disposable PPE, and decided that the scope of the study should really fall to the left of this diagram here, focusing on domestic waste streams, which is the kind of black bags, whether that's personal or in hospitals, and the low-risk orange waste stream, which is treated and made safe for landfill or incineration. But from documents such as this that we were looking at, this is one of the key reference points that we used. The NHS Scotland Waste Prevention and Reuse Guide, made on behalf of or in collaboration with Resource Efficient Scotland. It talks a lot about how a good percentage of the waste that's put into the orange waste stream could feasibly be diverted to domestic waste or recycling streams. So the opportunities that then start to exist, just trying to keep diagramming this, is to move away from the single-use PPE, which has a lifespan of under a year before it's put in landfill, to a system where we can recycle into building products which have a 15 to 20 year lifespan before they themselves are again recycled. So again, it's about locking in that waste. And starting to just try and map what that means out in terms of segregation, collection, sorting, processing, and remanufacturing, and the sort of industrial processes required. And also the barriers, of which there are many, and the report goes into more detail on these. We've also then tried to kind of group those barriers, which is what this diagram is trying to show, with some, there's kind of overlapping concerns with various kind of barriers that if you solve one, you help hopefully solve the other one. We looked at a number of case studies and had conversations with a number of people. There's some really great companies such as TerraCycle already recycling PPE, such as gloves and face masks. And we also looked at it from the other side again, from building products, furniture products, which use 100% recycled plastics. As part of the report, we were really starting to try and quantify, what what this means, again, from both sides, how much of this disposable PPE is being used and discarded, and if captured, what or how much of an impact could we make. So this slide tries to think about the raw material of that. There's 175 million aprons used between 2020 and 2021. If 100% of those aprons were captured and recycled into 12mm thick 2 metre by 1 metre plastic cladding panels, then you can make 50,000 plastic cladding panels. The NHS, the Waste Prevention Resource Efficient Scotland report makes the suggestion that a good target would be to recycle 15% of items that usually go into the orange waste stream in terms of PPE. So we use that 15% as a kind of baseline for our studies, and even if you only captured 15% of the aprons used, you would still be able to make 7,500 of those plastic panels, which is almost enough to clad one side of the Empire State Building. In terms of energy reduction, you'll see in this graph on the right that recycled polypropylene, polypropylene is what is used to make the face masks here. If you're recycling polypropylene to make furniture, it's much closer in embodied carbon emissions to plywood than it is to virgin PPE, and much more so than aluminium you see here. So between virgin PPE and recycled PPE, there's a 73% reductions for embodied carbon emissions. Plywood is obviously less than that in terms of making furniture, but speaking from experience of having successfully specified plywood in a healthcare setting, the amount of lacquer that you need to put on it to protect it from fire and infection control, I'm sure would shoot that value up much closer to the recycled PPE, which is wipeable. In terms of cost savings, it's obviously, well, again, from the Waste Prevention and Reuse Guide, where these figures in the top right come from, it's much cheaper to recycle waste than it is to throw it away and put it to landfill. So there's significant opportunity for savings. So even again, if we recycled 15% of the tonnage that we presented at the start of the presentation, that would reflect a saving of £250,000 a year in terms of waste management costs. We're also interested in sort of creating practical examples or practical sort of proof of concepts. So this is a kind of fairly DIY starting point that we did in our own studio, using a small heat press and some fairly standard issue plastic aprons. We also worked with Still Life Studio, who are a studio specialising in plastic recycling and products. So these are 3 prototype stool tops, all working with, again, NHS issue aprons, plastic aprons, where they were set in a mould and melted down to reform a stool. So this stool that we have created with them acts as a bit of a proof of concept prototype for what we can do. So this stool is made from, the stool top, is made from 200 plastic disposable aprons. The wider kind of applications you can see here in terms of being furniture, waste bins, the gloves are already being used in a small way to create rubber vinyl flooring, and that idea of remanufacturing the LDPE into cladding panels, again, is already being done with other forms of LDPE, so very much a sort of possibility. So our proposal is for a local and open loop remanufacturing system to capture as much disposable PPE as possible. The local refers to the fact that we have focused the report on NHS. And so I'm not reading the chat, by the way, so if there is things coming in and anybody wants to jump in.
Sorry, Andy, we'll take them at the end of your presentation. We'll just revisit them and answer them.
Fantastic. So NHS, so focusing on the local aspect of this title focuses on the fact that it's NHS PPE being proposed to be captured and remanufactured into building products for healthcare environments. The open loop aspect of it, or open loop remanufacturing, describes the fact that we are not returning the products to the same use, but we're returning them to a different use. But we hope in this case that that creates an argument for locking in the waste for a much longer period of time, which is a good thing in many respects, and that there's other studies hopefully being done which look at reducing, I guess, the dependence on plastic disposable PPE in healthcare. The remanufacturing flow start out sort of broad stroke strategy for segregation, collection, sorting, processing, and what type of things then specifically for healthcare NHS environments that these types of plastics can be remanufactured to. So things like cladding and panelling, furniture, floor tiles, plexiglass screens and partitions, and technical textiles, and each of these has a sort of proposed lifespan. This is an image that we've made subsequent to the issue of the report that just tries to kind of chart some of those applications. So everything in this image, bar the probably the curtain rail, the bed, and the doctor here, could be made from plastic, recycled plastic coming from PPE. So again, the nitrile gloves being remanufactured to flooring tiles, the polypropylene face masks being injection molded into furniture or objects, the PET and the polycarbonate being able to create technical textiles such as shower curtain or plexiglass screens for room dividers. And as we've seen a little bit more detail, the LDPE aprons being heat pressed to form cladding panels that you could use for areas such as wet rooms or shower rooms. So the next step for us is that we would like to take this to a more detailed feasibility study for each product. We would like to ideally create a one-to-one prototype interior, really kind of making this real, and then create a pilot program to capture and remanufacture plastic PPE waste, potentially with one hospital or healthcare centre. These are quite kind of ambitious steps, which would require obviously many more kind of sub points to make them happen, but we're looking for opportunities to kind of explore these next steps. Ideally, we would love to end up with something like this. This has got nothing to do with PPE or healthcare. We just thought it was a good image to sort of end on, you know, the idea of a kind of IKEA showroom where you can walk through and everything would be made from recycled plastic PPE. Kind of act as the next level of the proof of concept, and hopefully act as a bit of a catalyst for change. Give some, give some real sort of tangible outcomes for what can be achieved if we can start to capture and remanufacture this kind of growing waste issue. So that's my presentation. Hopefully I've kept almost to time. So my name is Andy Campbell. That's my email address and some details for the practice there with the website and the socials, which you'll get a little bit more information on the project through that as well. So thanks very much for listening. I'm happy to take any questions, Paul.
Thanks, Andy. So the first question we have is, can you buy the stools?
Yeah, so just to go back to the stools, you can buy those stools from Still Life Studio. You can't buy them with the recycled PPE just yet, but that is a standard product that Still Life Studio do. They use all sorts of, they usually use HDPE plastics, which are, you know, harder plastics to melt down. So if you go to Still Life Studio, you can buy stools very similar, but with different types of plastic tops. Yeah.
Brilliant. Another one is,
I can check them as well.
the other one is the products. So in terms of the performance of the products, did you actually test the performance of the products that had been developed from the waste stream? And are there any results? So particularly looking at the stools top, so we always see the IKEA adverts, the level of testing they do in terms of fatigue.
Yeah, no, I think that would be contained in the sort of detailed feasibility study. So that's something that we want to test. We would be, I think the test for any sort of cladding or furniture going in would be durability, like you say, the sort of I can't remember the name for that test. Durability, fire rating, and tests for infection control, which would be the sort of three main ones that are on the tip of my tongue. I'm sure there's others that we would need to test as a sort of detailed feasibility study.
Are we allowed to jump in? I wondered about comfort. You know, if it's made of plastic and someone has got to sit on it, because, you know, if it's not comfortable for the user, then it doesn't matter how good it looks or how no one's going to buy it. Did someone actually sit on it to find out, you know, how comfortable it is to sit on?
Yeah, I mean, well, just maybe two parts to that question. One is in terms of comfort. Yeah, I mean, it's a stool. It's not, you know, we're not sort of suggesting that this is replacing, you know, all the hospital chairs. And we're not even suggesting that stool is suitable for hospital use. What we sort of were presenting there was just a proof of concept, and we collaborated with Still Life Studio because they've got the infrastructure to recycle and form those plastic molds. The second part, yeah, I guess, well, maybe the sort of second part is that yeah, no, we're not presenting the stool as a solution as per se. I think what a much more viable option for especially the LDPE plastic to become as wall paneling and wall cladding for splashbacks, wipeable surfaces, shower rooms, etc., which obviously the comfort doesn't really come into that in the same way.
Okay, thank you.
No worries.
Thanks very much. Andy, there was a question as well in terms of, would you be happy to share the presentation that you've provided today?
Yeah, I mean, I guess it's with some caveats.
Yes, actually.
And yes, I think Catherine's also got a copy. But yeah, if you want to get in touch, I can.
And the final one is, how do you plan to progress this project and share your findings? Is there a particular funding call that you're targeting, or?
No, so I would also say that this is actually the first sort of piece of, if you want to call it, academic or university-based funding that we've received as a practice, or as a collaboration between practice and university. So I'm quite new to this. And we're, yeah, in terms of our next steps, you know, we would love to be hitting these types of things, but in terms of funding strategies and funding avenues, streams, I'm quite naive and would take advice from anyone who has any ideas for how we might take that forward. We're especially interested in speaking to people within the NHS. We think it's a really relevant study for themselves.
Brilliant. Thanks, Andy. Much appreciated. If you can stop sharing, and then I'll invite Zi Chen to bring up his slides.
Yeah. Thanks, Paul. Thanks for the questions, everyone. That's great.
Hi, Paul. Can you see my screen now?
Yeah, I can see your screen. It's not in presentation. It's in presentation mode now.
It is in presentation mode. Yeah, fantastic. Yeah. Good morning, everyone. Thank you, Paul, and thank you for the SRR organising this fantastic event. So my name is Zi Chen Zhu from the National Manufacturing Institute, Scotland. Today, my topic is repurposing disposable household face masks I'll first briefly introduce the background of this project, and then I will talk about the proposed solution together with some preliminary results. Right. So, well, first of all, who are we, and what is the NMIS, National Manufacturing Institute Scotland? What's this entity? So we are a group of industry-led manufacturing, research and development facilities where research, industry and public sector work together to transform skills, productivity and innovation to attract investment, and to really make Scotland a global leader in advanced manufacturing. So we are one of the UK catapult high-value manufacturing centres. Right. Yeah. So okay, this is the project background. So this photo was taken in a park near Glasgow. It's a very peaceful area. But while I was walking into this peaceful area, something that made me less pleasant. So that is the face mask. So and then we realized that the face masks are pretty much everywhere in our daily lives. So if you go to a supermarket, you can probably see the face mask in the car park, and if you walk on the streets, you can definitely spot a face mask. And it's been reported that face masks are found in oceans as well. So certainly it's kind of waste. So then we wanted to find out how the general public uses and disposes of face masks. So we ran a short survey. So the people in the UK were the targeted respondents, but we also received some responses from other countries in the world. So obviously we are now I think 14-15 months into the COVID pandemic, and we are not short of PPE anymore. But you can see that about half of the respondents would prefer to use single-use, that's disposable face masks, and then many of them would like to just wear it once and then dispose of that, or even just use it multiple times, but definitely going to get rid of that within the day. So that's about 60% in total of the respondents. And then when it comes to the category, which waste category that the people dispose of the face mask to, then we found that the people didn't put too much attention to the category. So let's say that you can see all these percentages, and then that's almost about 70% of that of the people saying that they didn't put too much attention. They put into the food or even to the paper, or they've not bothered with which waste category, or they even not considered about the disposal options, just to dispose of the face masks at personal convenience. I think one of the reasons was because that there was a misconception in the public that the face mask can easily degrade. So here you can see that only like 1/4 of the respondents realize that it's going to take more than 100 years or a few hundred years for the face mask to degrade. The majority of them think it's just going to take 50 years or less than 10 years to degrade. So people didn't think that was a big problem. But obviously the face masks are a waste. So like Andrew Campbell introduced in his presentation, so the face mask, especially the fabric that covers our face, the major constituent material is polypropylene, so that's PP. So that got us thinking. So because we are playing with the additive manufacturing technologies, so one of the mainstream AM additive 3D printing methods is fused filament fabrication. So that uses filaments as the feedstock material. So that is fed into the nozzle and heated through the nozzle and deposited onto the platform to form the 3D object layer by layer. So that you can see that the one that on the right. So you can produce many components, like unused components, as well as prototypes that we use in our daily lives. So then we thought, wow, good. the filament is the feedstock material that is made of plastics or composites as well. The PP is one of the most widely used available material for fused filament fabrication technique. So then we were thinking whether we could transform the face masks, used face mask, can transform the used face mask into the filament form, PP, and then that can be used for 3D printing. So that sort of fits into the circular economy concept. So that's what we did. So then we first separated the face mask into different pieces. So you can see that the ear loops and snap fit for the nose. So we only kept the fabric here. So then I think we've got like more than 8,000 face masks coverings. Then they were shredded into pieces, small pieces, 2 mil by 2 mil. That's roughly the dimensions. So these pieces were then heated at a temperature that was just a little bit higher than the melting temperature. Then we used the process that sort of like hot pressing to press the heated liquid into sheet. So these sheets then were put back into the shredding machine. Then they were shredded into granules. So granules were the material were the preferred form for polymer extrusion, and polymer extrusion is the process for producing filament. So we put the granules into the polymer extrusion machine, then it was extruded into filament. But we were facing a number of challenges. So one of the challenges that the filament diameter was not consistent. So one of the reasons was that we didn't actually, as a preliminary study, we didn't separate different layers within the fabric. So you can see on the right that there were 3 layers: blue and light white, and the one in the middle. So we were sort of like mixing different sort of layers with slightly different chemical compositions together. So that was one of the reasons causing the inconsistent extrusion. And another thing about that, another challenge was that in order to have a stable, consistent filament extrusion, then we needed to get high density of the liquid, but the fabric was at a very low density PP. So that was another challenge. That's something that we need to densify the material a bit more. And apart from the technical bits, I would also like to bring up the regulations and traceability. So the picture here shows that that was the setup in the hospital. So the used face masks were going into the autoclave, where the autoclave can heat up the face mask up to more than 200 degrees Celsius, to disinfect the used face masks. So I think important thing that we need for the government and for the science community to work on is that so when if the product is made of used face masks, the customer would need to know the traceability of it. So if you wouldn't want to buy a product that is made of a contaminated face masks. So that's something that I think that needs to be addressed as well. So that's pretty much the map presentation. Thank you very much for your attention. So I'm happy to answer any questions that you might have.
Thanks, Zichen. That's brilliant. So if colleagues have any questions, please raise them in the chat. I've got one, Zichen. What's your next move for this program? What's kind of some future work planned, or ideally, what would you do if you had some additional funding? Yeah, sure. Because we would like to go to more fundamental scientific studies on that. So we want to identify. We want to study the characteristics of the melted film, melted PP from the face mask. So that's about the rheological characteristics, and we need to measure the flow index as well. So that's something that can help us to get a more consistent filament diameter. So then that we can use that to produce to print parts from that.
So yeah, so we are having a hopefully we are having we're going to have a capital project to support that, but we are also targeting at the Europe Horizon project applications for that to take this project forward.
Brilliant, thank you. I don't see any other questions in the chat, so lightly there, Zhang. But thank you very much. If you could stop presenting, and I'll invite
Sorry, Paul, there's one question that's just popped up there.
I'm not sitting on my chat, sorry. Yes. Wouldn't it be easier if we worked on encouraging more of a general population to use reusable face masks instead of single-use ones? Want to comment on that?
Yeah, sure. Yes, that would be nice if people can be more cautious about the waste and the waste that we are generating. Then if we can reuse and use multiple use face masks, that would be brilliant. In the survey that we conducted, then people expressed the concerns that they would prefer to use single use. Just one of the reasons was that they think it's more it's safer, it's more hygiene, so people would like to use that rather than use multiple uses face masks. Yeah, that's obviously that's another aspect of this. Yeah,
it's a bit of education piece.
Yeah,
Shishang, that's brilliant. I'll invite Damola to present. Brilliant. Over to yourself, sir.
Hi everyone, good morning. So my name is, can you all hear me?
Yes.
Yes,
we can hear you.
Thank you very much. My name is Damola Akano, and I'm presenting on the environmental impact of increased PPE and medical devices manufacturing to fight COVID-19. And should I say that my research actually provides a background to understand the actual environmental impact of the increased PPE usage as a result of the COVID-19. And previous presenters have talked about, methods or ways of reusing, repurposing, recycling waste PPE. But I think even before that, the actual impact of the PPE, e.g. face masks, visors and all that have not really been put on a good perspective or quantitatively assessed. So I'll just take you, everyone's aware of what happened before pandemic anyway. I just quickly brushed through pre-pandemic. The use of PPE wasn't really widespread, and even in clinical settings, this was mostly reserved for critical conditions and all that. And the highlight for that was 1% of the NHS demand for PPE was only met by local manufacturers. But as a result of COVID-19, there's been a massive need, there was a massive need to produce PPEs. And in April 2020, the WHO estimated that about 89 million face masks and 76 million gloves, 1.6 million eyewears will be required on a monthly basis to fight COVID-19. And the impact of this is that every country needed to step up or to scale up their manufacturing activities to try and meet this demand for the PPE by themselves. And the UK government, supported businesses, to scale up their manufacturing activities. And, big companies such as Amazon, Royal Mint, Jaguar, Land Rover, and several other new PPE plants were set up across the UK. And by 2020 December, up to 3/4 of the demand for PPEs was met by local manufacturers in the UK. And particularly in Scotland, a number of businesses were involved in the deal to manufacture and distribute PPEs, such as the Alpha Solway, Honeywell, Keeler, Gentex, Seniors, and Plexus. And perhaps it's important to mention that before the pandemic, Honeywell's facility in Scotland actually specialized in manufacturing and testing services for industry-specific solutions and not actually PPEs, but they've had to go into PPE manufacturing to try and help the country. And also same goes for Plexus and same goes for Keeler. And the number of PPEs that these companies were engaged to manufacture, I'll just go through the numbers right now. So 4.5 million respirators and 70 million FFP and FFP2 and FFP3 face masks were manufactured by Alpha Solvay, and Alpha Solvay also were involved in manufacturing about 6 million FFP3 viruses, and the consequence of that was that 87% of Scotland's demand for PPE was not met by manufacturers based in Scotland. And the actual impact of that is that the demand, the raw material extraction, the materials, the manufacturing process, the transportation, the consumption and usage, and the end of life management of PPE became a very critical issue. And as a result of that, there was massive consumption of materials and energy and all that. So the implication of this basically is that the demand and the demand for materials and energy for manufacturing increased more than 100-fold between 2020 and 2021. And based on estimations, about 87 million face masks are used on a daily basis in the UK. And that's based on assumption of an average one person uses one face mask per day. And that's assuming that about 70% of the population actually accepted the face mask, which we know can be actually more than that. And the impact of that is about 7 million in Scotland. Now, according to the Worldwide Fund for Nature estimation, if only 1% of that face mask is inappropriately disposed, that would translate to about 26 million face masks monthly in the UK, potentially exposed to the environment. And by that, it could either be thrown into the environment and the floor, on the ground, on the field, in the water, and all that. And as Andrew and Zicheng stated, PPE is actually made by majority of plastic and plastic products, which are very hard to recycle. And the other 99%, which we assume are appropriately disposed, are mostly treated through incineration, which eventually produces bottom ash and greenhouse gases, which negatively impact the environment. So while preparing for this presentation, I ran a poll on social media and asked people to send me pictures and comments about where they've seen face masks being disposed inappropriately. And these are some of the pictures that were shared with me. Now, this is face masks in different parts of the environment, like in the water, and like the picture right here showing a fish, and all that, and people trying to actually make amends and pick it. And I think one of the greatest challenge we might have from PPE exactly might be PPE particularly might be harvesting it and actually collecting waste. And that's why we've come up with a number of recommendations to discourage as much as possible the use of single-use PPE, especially face masks, visors, aprons, and all that outside clinical setting. The reason for this is within clinical settings, it's easy to collect it en masse and then treat it appropriately through registered disposers or registered recyclers of PPEs. But outside clinical setting, it becomes even more difficult. And apart from that, another thing that was suggested is to make retailers, manufacturers, and suppliers of PPE become more responsible for the products that they sell. For example, I've been to a number of retail stores and I asked them about if they have any specialized waste bins for PPEs, for example, to encourage their buyers to say, if you don't want to dispose it, if you don't know how to dispose it, you can take it back to where you got it from. I just throw in a special. It doesn't have to be inside the store, but somewhere around, the environment. Most of them don't have it, and I mean that actually pushes customers. It's not an excuse, but it pushes customers to want to dispose it off anyway. But I think if manufacturers, suppliers, and retailers become more responsible, it would actually help us improve existing network for the collection of PPE waste. And also, we need to begin to work out ways to actually collect, sort and recycle, repurpose and reuse waste PPEs. And I think previous presenters have done I've talked in good detail about reusing, repurposing, remanufacturing plastic product. But I think more work would be required, more investment, more research would be needed to actually go into more detail to reuse, to remanufacture used PPE, because I think that's not a problem right now, but in the next few years, in the next few months, it would constitute what might be a very global, a very big environmental issue. So that's the end of my presentation, and thank you very much.
Thank you, Damola. That's very good. And in terms of your next steps, where would you encourage for this work to continue to, if there was funding available?
Yeah, so I would like this work to be expanded to cover a little more products, more resources, more materials that have been manufactured as a result of COVID-19, not just to the face mask or the aprons or the visors, but to actually go further than that and to focus more on more materials. And another thing is to use the numbers and the results from this research as a means to convince stakeholders within this particular business to see the impact of what they're doing, to see what it can cause in the long run, and to help them, to actually encourage them to take more responsibilities for, for the collection and the recycling of their products, and also to, of course, encourage people in academia and industry to work together to try and combat this very serious issue. Thank you.
Great, thank you, Damola. So I'll just look at the chat. Are any parties wanting to ask any additional questions before we move on to the next presenter? No, okay.
All right.
Thank you very much. If you stop presenting, and then we'll invite George Chen to present.
Yes, Paul, thank you. Give me a second to share my screen.
Not a problem.
So can you see, Paul?
Yes, we've got it in PowerPoint mode.
Great. Hello, everybody. So welcome to my presentation.
Sorry, George, my apologies. Do you want to put it in presentation mode? We've just got it in the PowerPoint software mode, but you can.
Yes, I'm trying it. It's good.
There you are. That's good. Thank you, sir.
Okay, thank you, Paul. So good morning, everybody. So welcome to this presentation. So my focus through this funded research project is to identify waste and the solutions to reduce those kind of waste in the use of PPE against coronaviruses in Scotland. So my focus was over on two work stages of the built environment from construction site point of view. So one is on the construction stage and another is at the operation stage. So this is the overall aim of this small project. It's about 1.5 months only. So there are a lot of limitations I have to say with regard to the coverage and the findings. So as I mentioned, I have two focuses on different work stages of the built environment. One is on construction, another is on operation. With regard to the impact and spread of coronaviruses in the built environment, so we pick up several key special sectors for operation stage. These include hospitals, care homes, shopping centers, supermarket, public transportation, and school universities. And for construction, we focus on the what happened on construction site. So this is the scope of this small research. With regard to the overall research aim, there are four research objectives. The first one is to establish a generic methodology for research into the identification and the reduction of PPE waste from the two work stages of the built environment. And in terms of built environment, the coverage is to buildings and civil infrastructures. So I think the first objective is to make the research a little bit more influential not only for this project, but beyond the funding time period, to facilitate further research into this big challenge. The second objective is to identify PPE waste streams from construction operation stage of the built environment. And this is a kind of implementation or use of the generic methodology mentioned in Objective 1. And the purpose is to use this small project to try whether that methodology can be useful to in waste identification. And the identified streams from at the 2 stages in terms of PPE waste can inform the improvement of practices in terms of PPE usage and something additionally, for example, waste management, in order to reduce PPE waste. The third objective is to identify the possible quantity and reduction solutions in this area. And as this is of the imagination before this proposal was submitted, that although it's important and crucial to use PPE to protect workforce at the front line in this combat against coronaviruses, there might be some alternative solutions to reduce PPE waste. So this is something was kept in mind when we developed the research in this project. And the fourth objective is to report findings to SIR and also with Scotland. So this is a very simple, straightforward research objectives. With regard to research findings, we under the 4 objectives, the first one is the so-called generic process map as a new method to support the research into PPE waste identification and reduction in the construction sector with regard to the 2 construction, 2 work stages on construction and operation respectively. In addition to that, or behind this is something to inform the design of the built environment. So this is to try to close the loop in the life cycle of built environment development. This is a conceptual process map to put forward through this project. So on the top of this map is the key work stages with regard to the whole life cycle of built environment. So from design to through construction to operation and then redevelopment. And now we are trying to add the element of PPE usage into the life cycle, and with regard to the 2 key work stages on construction and operation. As I mentioned in before, so we have several key focuses among the very important sectors in this combat, including healthcare, supermarkets, transportation, and school. And in addition, there is an ongoing project. And we try to collect data through questionnaire-based survey through to those identified sectors. And we also have some additional research activity conducted to support the questionnaire development, and also some other discussions based on what could find from the survey, and eventually this framework can form a so-called research project described here, and the outcome will be used to inform construction and operation, and also I mentioned the design as well. So this is something I'd like to share with you as a first outcome. The second outcome is to use that process map. We develop a series of six questionnaires to collect data from the practitioners, and we have 6 questionnaires, and the focus is in Scotland. So those questionnaires were shared online. So for example, there are 3,700 views on 2 LinkedIn groups, and this is from my personal share, and also there are two colleagues working for this project, which I will show you at the end of my slide. So they also shared their post on LinkedIn, attract many views. This is to increase the impact of this research and to draw more attention to this very important issue. And we also try to maximize the impact about this research by using about 98 hashtags while we are sharing our post. And these are shared among 21 LinkedIn groups with a huge number of members. Hopefully they were well reached. And also we circulate or send emails to call for participation, and those emails are probably several hundreds. So this is about the second one. Unfortunately, the total response we received is 44 across these 6 sectors. And most of them are from Scotland, indeed, but I think the sample size were not good enough to form a convincing solution. So I think from that point of view, we further conducted a literature review, and there are some very important references. For example, this is from NHS Scotland and England with regard to the use of PPE in the first year combating the coronaviruses. So 1 billion items, PPE items were distributed in Scotland, and more than 10 billion used in NHS England. So this reflect what my colleagues presented before with regard to the important issue and the demand for the recycling and reuse of this kind of used PPE items. So for this project, I think these numbers are shocking, and the key from my point of view is how to reduce the demand of PPE items as the front line. So my proposal is to use alternative technical solutions, ITS. I think although PPE equipment is crucial to protect frontier workforce, but there may be some unnecessary use PPE through the statistics showing before. So this will leave a space with regard to whether we could have some alternative solutions to protect people at the front line. In the meantime, to reduce unnecessary use of PPE. And the alternative solutions at this moment from my report, will cover new materials, new equipment, devices, and also new work procedures. So I hope from these three dimensions, we may define a set of ATS for better use of PPE and protect from people. So one example with regard to ATS is the use of far UVC light, which is harmless to human being or human body. So this has been widely used at some important built environment to disinfect the indoor environment caused by coronaviruses. And this is one example. Sorry, so I clicked I think this is something. Well, let me move on. So in the United States, this is a kind of conceptual prototype proposed for healthcare environment, for example. So for all type of building environment, including schools, supermarket, so this is a kind of alternative solution for building professionals at the design stage to carefully consider whether this technique can be better or thoroughly used to protect people through this disinfection process in a daily basis. I think the rest of research outcome is quite simple. The third one is a data set to be extracted from our questionnaire-based survey, and then a report which has been submitted to the SHARE for review under revision. For further effort through this funded project, so I led a similar issue on the managerial responses against coronavirus. So at one journal published in Switzerland, it's open access journal. And at this moment, we have 3 articles, and hopefully we may have more to come. So if you have interest, you can visit
Thank you, George. That's absolutely brilliant. I'm looking at the question. So there is one. Do you see the UV light? Does it make the space have a purple or blue hue? Does it impact the visuals of that environment?
I think this is a very interesting and good question. To be honest, I don't have such experience, but it looks like a purple color. It's different from the traditional UVC light, which I have experienced. So UVC light, when it's turned on, people need to remove from the room, for example. But for far UVC light, it looks safe. We can stay inside. So with regard to the color, I think this is a very interesting question. So if you have interest, probably you could check what researchers has been done at Columbia University in USA, so regarding how the adoption of far UVC light could won't disturb our normal need for lighting. And the last slide shows another two colleagues. Function one is a research assistant for this project. Ahmed Salim is a volunteer. Thank you.
Thank you, George. That's absolutely brilliant. So what we'll do is we'll invite the next speaker, Kingsley, to share the presentation. Whilst he uploads his slides, can I just ask everyone just to double check that they're on mute, just because we're getting some background from parties. And over to you, Kingsley. We can see your slides, it's just not in presentation mode yet.
Okay. Can you see the slide now?
We can see them in note form, so I think we want to see the other screen.
Let me see. Slide. Okay. Can you see it now?
Again, it seems if you've got a split screen, we're seeing the other screen where we can see your notes.
Okay.
They
Is this better now?
That's it.
All right. Thank you. All right. Thanks so much. Thanks so much, Paul, and the organizers, Scottish Institute for Remanufacturing. I appreciate the opportunity. So I'm talking on my research on sustainable manufacturing strategies for PPEs in the light of COVID. Also appreciate Professor Winifred Ijoma for her kind support. This study was conducted around March, so it's a snapshot of what was happening in the light of COVID at that point in time. The aim of the study was to look at sustainable manufacturing strategies and how it could be applied in the health sector in the light of COVID. I have a medical background. I also work with the NHS, and so that's feeding into this presentation as well. The objectives were to identify what the current manufacturing practices are, evaluate their impact, and analyze how sustainable manufacturing could be applied to PPEs, and to recommend sustainable manufacturing opportunities. So looking at things like reuse, remanufacture, recycling. So as a qualitative research, grounded theory methodology was undertaken. There were initial literature review was undertaken with observations and informal interviews of healthcare providers and suppliers. And these were coded and analyzed using NVivo 12. And the results were triangulated to inform the findings of this research. So COVID is a pandemic infection. About 181 million cases recorded globally. And sadly, we have 3.9 million deaths. In the UK, about 4.3 million, 4.7 million cases worldwide, with 120,000 deaths. And the number of deaths has slowed down with the vaccination program that's currently going on. So in response to COVID, there has been an increased demand of PPEs, as the other speakers have demonstrated. Increased use in the hospitals. Initially, the government were suggesting that face masks, did not play a role in stopping the spread of COVID, but there was later a policy change. So you have more people in the public using face masks. And so there's a potential threat to the environment, as we saw from the other presentations, both in the wider public environment and in the marine environment. So currently the current personal protection equipment are made from polypropylene, which is potentially recyclable. But there's need for appropriate waste disposal framework. Some of the PPEs, as were shown in some of the slides, I think it was Damola and then Zhu Chen. Some are being washed into the sea. Some are being, thrown on the streets. So in the market, face masks are also being made from cloth. So there's a potential. One of the findings from the research is that there's a potential for use of reusable cloth-based face masks. I think it was Andrea that was asking the question. Reusable cloth-based face masks is widely available in the public. People use it for longer, for more months, and it can be washed and reused compared to the polypropylene face mask, which is traditionally used once and then disposed of. So there's a big potential for reusable cloth-based face masks. Then we know that in the surgical wards, surgical gowns are being reused as well. But in terms of the use of face masks, the finding from the study suggests that people may not be comfortable reusing a face mask that has been used by somebody else. But if they have used the face mask themselves, they're happy to reuse that face mask. So reuse of fabric-based face masks following sterilization is one of the possible outcomes or strategies. Then paper-based PPEs that can easily be recycled could also be used. Tear-resistant, water-resistant aprons or paper gloves is one of the potential strategies that could be used. There's some techniques we also identified for breaking down the polypropylene-based face masks. One of them is pyrolysis, in which the polypropylene is broken down to a biofuel. The polypropylene-based products are exposed to temperatures of up to 300 to 400 degrees without oxygen and are converted into renewable fuel. And it has been demonstrated to be better than landfills and incineration. Another technique is that of photoreforming, in which sunlight is used to break down the polypropylene into renewable fuels. And there's an estimate that it could save up to 700 million pounds yearly if just 1% of PPEs in the NHS go through this process.
That's a minute warning, Kingsley. Sorry.
Okay. So systematic waste strategy is needed. As you can see, the use of polypropylene waste bins. This was seen in one of the supermarkets in Scotland. So in conclusion, the current practices are unsustainable. There's a scope for shared learning. There are savings in terms of the amount of polypropylene that can be used to produce face masks. Recycling of polypropylene should be evaluated. And then policy gaps. UK wide policy waste management strategy is needed for dealing with PPEs. Thank you very much.
Thank you, Kingsley. That was absolutely brilliant. I will just quickly review if there are any questions in the chat. I can't see any at the moment. Kingsley, what would be your recommendations for future work?
Okay.
Opportunity.
Okay, like with the research, I think one of the areas we want to look at is what would be the environmental impact of using cloth-based face masks compared to the polypropylene-based face masks, in terms of energy, in terms of waste. We want to look at the different kinds of fabrics, which fabrics would, are more effective than others, and then also the settings, which, for example, like in a care home setting, hospital settings, infectious disease settings, what kind of fabric-based face masks would be applied in those areas. And then lastly but not least, we'll be trying to develop a process map for an appropriate waste management strategy UK-wide. Thank you.
Can I point just one more? I know, thanks a lot, Kingsley. I think another one we want to look at, is also the reverse logistics and forward logistics as well, because to get the face mass back in the right quantities and the right conditions to be able to make something else with them or even to reuse them, you have to look at how you actually, the process of the people that have the face mask, returning it to the people that are going to use it. So reverse logistics is one. The other one is coordination and communication and coordination. So there's must be a way for the people that have the waste, PPE waste, to be visible to the people that are able to use the PPE waste, the costs associated in the reverse logistics, the costs associated with actually, and with the cost of the PPE waste itself. And last but not least, and some of this has been covered by Andrew, is also we need something like a physical library showing the sort of output you can get from reusing such waste so people can see for themselves, because you can talk to people all you like, but they need to actually see it and feel it. In addition to that, we also need a digital library of such waste as well.
Thanks, Winnie. Good point. Very good point. So thank you very much, Kingsley and Winnie, for the additionality there. I want to speak with the presenters today to find out what additive variations of presentations we can share with the audience, and we'll also amalgamate all questions asked and obtain responses to that and circulate that with parties. All that's left is thank you very much for partaking in today's event. What I will do is I'll invite our sponsor, Zero Waste Scotland, for any closing remarks to some of the content that's been seen today, and potentially any questions. Colin, any remarks on what you've seen today?
Yeah, hi everyone. Fantastic to see the presentations today. Well done to all those involved in the project. It's been a great opportunity to start a conversation around the challenges of a PPE, and in particular the recent volumes, I guess. And I would encourage anyone that's kind of attending today can support the projects to get in contact in any way. But yeah, thanks, Paul. It'd be great to see them all this morning.
Thanks, Colin. And I guess please do stay in touch, particularly with the Scottish Institute for Remanufacturing, if there is interest in some of the presentations you've seen today, or there are ideas of future work where you can see some collaboration across programs that you've seen presented today, because we would be keen to help support even an application into the Horizon 2020 Cluster 4, looking at sustainable practices, and we're sure that PPE waste streams are part of that interest area or challenge. Other than that, thank you very much. We can bring this session to a close. It will be posted on the Scottish Institute for Remanufacturing's website if you want to re-watch any of the aspects, or please feel free to contact us at our general inquiries email that can be found on the website, and stay in touch. Other than that, thank you very much, and we'll have a good week. Thank you.